we're going to be looking at your review or exam questions for arithmetic sequences and series. This is the last one in this series. And this question, I've written it out there for you in more detail. The sum of the first 5 terms is 70. The sum of the first 11 terms is 352. And they want you to find a number of different things. The first term, T1, or A for some of you, D, or the common difference, and then the sum of the first 30 terms, the sum of the first 50 terms, and also a more complicated question, and that is, what is the sum of the terms between 35 and 40? This is a more complicated question. We're going to deal with it and get some formulas for this to help you. Our sum of any number of terms is going to be equal to the number of terms divided by 2 times twice the first term plus n minus 1 times the common difference, like that. So let's assume 70, that's this number here, is equal to the 5 over 2, that's n is equal to 5, times, we don't know what the first term is, so I'm going to go 2 t1 plus 5 minus 1, 4 times the common difference. We don't know what the common difference is, and we don't know what the first term is, but we do know how to sum the first 5. Now we have 2 unknowns, 1 equation. This gives us another equation. Let's do the same thing here, only this time I'm going to write out 352 is equal to, the number here now is 11, so it's going to be 11 over 2. This is still going to be 2t1 plus, now it's going to be 11 minus 1, 10 times d. Let's see if we can simplify these equations a little bit. Here we have a 2 and a 2 and a 4. We can take this 2 into each of these. This 2 can cancel here with this 2 and make this 2 into a 2. Sorry, I hope that's not confusing. There we go. Now we just have a 5 times all of this. And the same thing can go over here. This 2 can go into both of these, making this a 5 and this a 1. Now we have slightly simpler equations. Let's multiply them through. In this case, we have 70 is equal to 5t1 plus 10d. 10d right here. 5 times this, 10d. So this is this first equation. And then the second equation is this one. We're going to multiply it out. 352 is equal to 11t1. And then here we multiply this plus 55. So here we have 2 equations with 2 unknowns, and it doesn't look like it's easy to handle. However, if you look at them a little bit more carefully, you'll realize, oh, there's a 5 in this, a 5 in this, and a 5 in this. So can we simplify that? I'm going to take this down here. Let's divide this by 5. So 70 divided by 5 would be 14 is equal to t1. This divided by 5 is 2d. So I've just taken everything here and divided by 5, and that's this equation right here. Now the second one, a little bit more complicated, but notice there's an 11 here. There could be an 11 here. Is there an 11 here? Is 352 divided by 11 some nice number? Yes, I calculated this to be 32, which is very handy, because now we can take all of these here and divide them by 11. And I'm going to get, I'll rewrite this over here. Okay, now here, I've rewritten this here, 5, that becomes d1, 352 divided by 11, I said that was 32. So now we have 2 equations, 2 unknown, much easier to solve than what we had before. Now the easiest way to do this, since this number is smaller than this one and this number is smaller than this one, is subtract in that direction. Of course, if I had been super smart, I would have written this one below this one, and it's easier to subtract. Subtracting upward, this minus this is 3d. This minus this is 0, that's why we do this. This minus this, if this was 12, this would be 20, but we have to take 2 more, so that's 18. Now divide both sides by 3, and you have d equaling 6. All right, that was a big part of what we needed to do. We needed to find d, so d is equal to 6. That makes a big difference. Now that we have d, which is 6, we can go back to one of our previous equations. I erased it, but I just rewrote it up here for you, that t1 plus 2 times d is equal to 14. Because in our equations, remember, we had t1 and we had d, both of them unknown. We eliminated t1 to get D. Now we can go back to those equations and just simply solve for T1. So T1 plus 2 times this, which is 12, is equal to 14, or T1 is equal to 2. So I can write that in there. T1 is equal to 2. Now we've solved some of the simplest stuff that we need here and here. Now we need an equation for the sum, because they're going to want the sums here, here, and here. So let's see if we can draw that up using a different color. If you remember your sum equation here, your sum, you had two different ones. One of them was the first and the last of your series or your sequence. We don't have the first or the last. We haven't developed those. We want a general formula for it. So that was n over 2 times 2 times T1 plus n minus 1 times D. One of the reasons they have you do these over and over again, so that you write the equations out over and over again, you get them into your memory, and hopefully be comfortable with using them. T1 is the first one, so we can write that in there. D is 6, so we can write that in there. So let's see if we can create a general formula for the sum. N is unknown. 2 times T1 is 2 times 2, which is 4, plus n minus 1 times D, which is 6. Now let's multiply things through here. I'm going to be left with a 4 plus 6n minus 6. 6 minus 6, 6n. I'm just doing the stuff in the brackets here. This here, of course, 6n minus 2. This becomes 2. Now we have this in the brackets becoming 6n minus 2. I'll multiply everything or divide everything by 2. We're going to have this being a 3 and a 1. So I'm going to go 3n minus 1 times n. You could bring this in here, 3n squared minus n if you want to. Either way, both are totally correct. So I'm just going to write the formula out here for the sum of n is equal to 3n squared minus n. Find S30 and S50, the sum of the first 30 terms, the first 50 terms. It's just simply a matter of plugging them in there. I'm going to do that up here. Here would be the 30 and here would be 50. I'm going to do them sort of side by side. So plugging this in here would be 3 times 30 squared minus 30. And here would be 3 times 50 squared minus 50. Here I've just typed these into my calculator, 2670, 7450 for the sum up to 50 terms, including 50 terms, and the sum up to 30 terms. So that's the answers over here. Can I just write them in really small here? 50. The last part of this question is the more complicated part. Let me erase this here and see if we can work that out. So they want the sum of all the terms between 35 and 40. So think about that for a second. 1, 2, 3, 4. Let's say you wanted all the sum of the numbers between 5 and 7. How would you do that? Well, here's 5, 6, 7. If you took the sum of all the terms 1 to 7, you would get all of these. Then you'd have to subtract these out. So to get the sum of all the terms 5 to 7, you'd have to go with the sum of 7 minus the sum of one less than that. One less than this, so 4. So it's the same thing over here. So if we want the sum of all these terms here, we're going to have the terms between 35 and 40. So the terms between 5 and 7, we'll get the sum of 7. So let's do that over here. So we're going to want the sum of 40, of the first 40 terms. And then we're going to want to subtract not the first 35 terms, because that would include this 5 here. You want to subtract one less. Subtract the sum of 34 terms. So we just plug these basically into this formula again, like we did before, and we should come up with a nice little answer there. And then subtracting, don't forget the big brackets here, so you do the same thing here. 3 times 34 squared minus 34. I got 1326 for all of this. You can plug this into your calculator yourself. So that would be the total number of the sum between 35 and 40, of course, including the term 35 and including the term 40. This was a little bit more complicated one. Hope this helps as we walk through arithmetic sequences and series. Remember to like this video, subscribe, and then in our next section, we're going to go on to another section of grade 11 pre-calculus practice test. Hope this helps. Have a great day. Bye-bye.